I hope you're ready because today we're diving into even more detail about ionization energies. Make sure you're up to speed. Check out the previous episode on ionization energy where I go through all of the key definitions and equations you need to know. We're going to build on that knowledge now and talk about the factors that affect ionization energies. So let's get into it. The main factors affecting ionization energies are the nuclear charge, the distance from the nucleus, and electron shielding. So those are the three different elements that we're going to talk about today. Let's start with distance from the nucleus. Electrostatic attraction decreases sharply with distance from the nucleus. This means that less energy is needed to remove electrons which are further away, which makes sense, right? This means that as distance increases, ionization energy decreases. In practice, this means the higher the principal quantum number of an electron, the lower its ionization energy. If that phrase, principal quantum number, strikes fear into your soul, make sure you check out some of the earlier episodes in this revision series. I go through it, talk about it in the electron configuration episode, so get up to speed with that. Let's move on to talk about shielding, okay? The greater the number of electrons between the nucleus and the outer electrons, the lower the effective nuclear charge. And this is because the positive charge felt by the electron is reduced by the electrons in between. So the greater the number of electrons, the lower the ionization energy. Electrons, they're negative, they repel each other, they're not friends. The nuclear charge, let's talk about that guy. The greater the number of protons in the nucleus, the greater the attraction of the electrons to the nucleus. A greater attraction of the electrons means more energy is needed to remove the electron. So the ionization energy is greater. So we went through those three factors quite fast, so let's consolidate some of that knowledge. The strength of the positive charge from the nucleus is felt by the outer electrons is reduced by the electrons in between. So the more electrons, the lower the ionization energy. Do we remember the term for that? That is shielding, okay? So shielding is really important when we're talking about ionization energies. The electrons repel each other, so the inner shells repel each other, pushing the electrons further away, making them easier to remove. So there is some experimental evidence for shells, which is important and can come up in your exam. Successive ionization energies are what we look at to provide evidence for shielding. If we look at the trend of ionization energies of an atom, let's take sodium, for example, we can see that sodium has the electron configuration 1s2, 2s2, 2p6, 3s1. Its first ionization energy corresponds to the removal of electron from the n equals 3 shell. That is that 3s1 electron. The second ionization energy corresponds to the removal of an electron from the n equals 2 shell, from the 2p6 shell. Between the third and ninth ionization energies, an electron is being removed from the n equals 2 shell of an increasingly positive ion. Then finally, the 10th ionization energy corresponds to the removal of an electron from the n equals 1 shell. Remember, the first few shells hold 8 electrons, and then the first shell holds 2 electrons. So that can help when looking at this trend. So ionization energy increases with proximity to the nucleus. The n equals 1 shell will have a higher ionization energy than the n equals 2 shell. The n equals 2 shell will have a higher ionization energy than the n equals 3 shell. And within the n equals 2 shell, successive ionization energies will rise as the ion becomes more positively charged. And those trends are all shown when we examine the ionization energies of sodium. So that's some very good evidence for these trends. So let's consolidate that. We see large jumps in the trend at the second ionization and 10th ionization energies. And this is because we remove an electron from a new, smaller electron shell. If there are more protons in the nucleus, it's more positively charged, remember? So a more positive nuclear charge means more energy is required to remove an electron. So once again, why do we see that large jump between the second ionization energy and the 10th ionization energy? That's because we're removing an electron from a new, smaller shell. That 10th ionization energy in sodium, we're taking the electron from the first shell, which is going to be really close to the nucleus. So we're going to need all of our force and might to rip that electron away. Okay? So what are those three factors that affect ionization energies? So nuclear energy, the distance of the electron from the nucleus, and the electron shielding. What's going to be the lowest ionization energy of sodium? It's going to be the first ionization energy because that's where the electron is furthest away from the nucleus. Do we remember what shielding is? And do we remember the trend for shielding? So shielding is where the increase in number of electrons between the nucleus and the outer electron leads to the decrease in effective nuclear charge. So that's that definition of shielding. Really, really important. So that brings us to the end of this episode. I hope everything made sense. Make sure you check out the module to consolidate that knowledge. And good luck with all your revision. Well done for being proactive. Keep checking out these episodes, get up to speed, and good luck.